Okay, welcome back, folks. All right, so you see what we're dealing with here as far as the testing. that's really all we got left to do other than just review. So I've been today working on any questions that anybody has. So I was going through the review. I can just continue to do so. I think we got up to about 20.
Yeah, I couldn't get number 24.
All right. Well, we'll get. What was it? Just a curiosity. Okay. Let's go back to 20 and just make sure we get all of them. Okay. So the table, I mean, also you can use some calculators. Your calculator doesn't do the standard normal, but these things are universal. That's why, the whole idea of calculating the z-score, it's got to be done a certain way. You take the difference between the mean and then divide it by the standard deviation, and that tells you what your z-score is, how many standard deviations that value is. So if we are looking at a table and they ask us to the left, then all we're going to do is we're going to take that value from the table, and that's going to be our answer. So on the column is the first two digits. The number in this case is the 1. We got the decimal point, and then we've got the tenths. So what we're looking at is we're looking at this row now. All right. Find the error to the right of the z-score 140. Oh, okay. I see why you're asking about it. Okay, because it's asking two things. Let me see if I can show you with that little graph thing that I got. And then it might make it a little bit easier to handle. Okay. Because what I read first, I just saw to the left, but I didn't see this part over here to the right. So there are two z-scores. All right. So what I'm going to do is I'm just going to show you on here 140 and 158. So it's above 140. Something's not right. I got to go back and look at it. And to the left. So this is what it is. Okay. It's 1.4. I don't know what I'm putting in. All right. So this is essentially what they're asking. They want what's below to the right of 140 and to the left. So really what they want is this one. They're just not saying between, but that's what it is. All right. So they want to know what that area is. All right. To the right of this value, right there, that first right there on that left side, that's the 1.4. And then the 1.58 is over here. So what we need to do is we got to look out both. And then we're going to subtract. Okay. So let's do the 158 first, since that's the bigger one. So that's this one right here. So that represents the 0.9429. In other words, it's 94%. And in the 140, there's this one right here. So that's 0.9192. And we're just going to subtract. There's only one way to subtract, the smaller from the larger. If we do it backwards, it will come out negative, and we just need to take off our negative sign. But let's go ahead and do this. So then that's says find the area. So then what we're going to put here is 0.0237. Okay, because again, it's got two things they're asking for. To the right of Z.14 and then to the left of 1.58. And again, looking at the picture, this one right here is the 1.58 and this one is the 1.4. So we're only looking for that small little chunk there, and it's essentially a between. So that's why we subtract 0.9192 from 0.9429. Okay, Tori, does that make sense?
Yeah.
So a normal distribution has a mean of 15 and a standard deviation 2. Find the value that corresponds to the 75th percentile. Well, the 75th percentile just means when we have 75% of the data underneath the curve. Remember, everything underneath the curve is 100%. So then 75 percentile would be this here. So that's here and here. So that's 0.68. So in other words, 75% of the data is below 0.6. So it's, hold on a second. Maybe I didn't get it high enough. Let me go back over and look. Oh, it's 0.68. Yeah. So see that gets us up to 75. We want to make sure we just go barely over the 0.75. The first one, that's 0.75. This one wasn't quite 75. This one was, so that's the one we use. And so 0.68. All right, so find the area to the right of, okay, to the right of. So this means we got to use our complement rule. So they're telling us the z-score, so we look that up. So that's 0.41. So to the right is 1 minus 0.6591. So say that, oops, that's 1. Oh, it's 0.6591. So then this is going to be 0.3409. So to the right, so we use the complement rule. Okay. Who was it? Was it Tori that you had the question on this one? Did I answer the question on it?
Yeah, that was the one that I got wrong.
What was the problem? You forgot about the complement rule?
Oh, I
Yeah,
don't, but I
because
did it
it's,
on Friday.
yeah. Oh, wait a second. This is a different one. Okay, that's this one. All right, so there's this one. This is the 24. Okay.
Yeah.
I put it in the wrong spot. That goes up here.
I kept on getting 2.4998 and that wasn't
Well, let's
right.
see what happens. All right. A normal distribution is observed from the times to complete an
No.
obstacle course. Oops.
Yeah.
It's a real small problem in it. Use the table to compute the probability of the z-score less than 1.96. So this is just the value straight from the table. So negative 1.96. And that's essentially just the value from the table.
Gotcha.
2.5% is what that is.
Okay.
That's a pretty standard one. If you take regular statistics, like 2 or 3, you'd see that more often. That's 95%. I mean, negative 1.96 is a common one. All right.
And so when we did the number 22 just now,
Uh-huh.
the correct
22?
the correct answer I got was 16.35, the 75th percentile one. I came up with 16.35. It said it's correct.
Okay, you know what? I didn't work the whole problem. Okay, I got the right z-score, so we got to calculate now.
Okay.
All right. Thanks for all right. I forgot which one it was now. It's this one. All right. So 0.68. All right. Find the value. Okay. That's the z-score. So what we got to do is we got to just go ahead and calculate. So we want to find the value. Find the value that corresponds. So that is right. That's the z-score that corresponds. But if we want to find out whatever this is, if it's some kind of a test or what, then what would be the score on that particular test? So again, this is probably the best way to do it. So 68 times 2. So that's 136 is equal to x minus 15. And see, you're multiplying that to 1 times x minus 15 is still just 1. So then we're going to add 15. So these are going to be gone. So 151. How does that sound?
No, I multiplied the 2 times the 0.68, and then I added the 50. I got 16.35 was the right answer. I don't know.
So 68. Oh, wait a second.
0.68.
It's 0.68. So it's 1.36. I'm sorry. All right. So 1.51. We may have to come back to this one.
Yeah, because
That's
I'm
the way to
getting
do it.
16.36 on my calculator, but last time I did it, I came up with 16.35. It told me what the right answer.
All right. Let me double check this. So 1.36 is equal to x minus 15. Oh, I see what the problem is. 16.36. There we go. There we go. Sometimes I just want to get things through things too quick, and I don't finish them. So that's probably what happened. That's what happened here. Twice. So then, see that score of 16.36. Minus the mean. So that gives us that right there. And then if we divide it by 0.68, then we get the 2 back. So that should be it.
I don't know. I was off by one. It accepted my
Well,
16.35. Is that
I may have not. Let me just see. It may not be that accurate, you know. In other words, it may give you some leeway.
okay?
Okay, so 0.68 times 2, and then we're adding 15. Well, how did you get the 5 then? Because 0.68 times 2 is.
I don't know. I did it. I don't even have, I can't find the workout sheet that I
All
did.
right. Well, like I said, I wouldn't worry about it if it gave you credit. All right. Just took me a while to get my brain wrapped around that one. I just read it wrong the first time, and then I made that little mistake when I subtracted, trying to make it quick. All right, a normal distribution is observed from the times to complete an obstacle course. The mean is 69 seconds, and the standard deviation is 6 seconds. Using the empirical rule, what is the probability that the randomly selected finishing time is greater than 87 seconds? All right. So let's just go ahead and do the z-score. So it's 87 minus 69 divided by 6. So this comes out to 3. So greater than 8.7 seconds. It's that, I'll just show you. It's basically the same question as one that I had in here. Where was it at? It's right here, yeah. So it's basically whatever little bitty piece is out here. In other words, above 99.7. Let me just make sure what the question was asking before I. I don't know. They're seeming to use empirical rule, and I guess that means that it's easy because with the empirical rule, so it's just that little bitty piece right up here. So it's a real small piece because basically what it is, and I'll just show you. Okay, there's 99.7 between. So 1 minus 0.997 is that little bitty piece right there. But we're going to split it in half because we just worried about the part that's on the top. So that's what that is right there. It's not going to be that accurate because of the fact that, oh, they wanted this percent. So that means that we're going to bump it up to 0.13%. Oh, wow, that was all of them. Anybody got anything up in the beginning? So, Justice, what was that problem that you said that you wanted me to look at? not the thing with the grades. I think you got to go back in and review it. That's the only way you can do that. Because I just see the grades as far as I know. But I thought you said there was a problem. You had some numbers listed. All right. So, I mean, just work. If you got a question, let me know. We got a little bit of time left, like 45 minutes. I'll be right back. I'm going to get my water. Oh, exam review? Uh, can you like send me a screenshot of it? Because I didn't see anything on there about what it was asking. But I'll go back to the top on this. The range is simply the lowest subtracted from the highest. So these are there's the high and that's the low. So subtracting should be 0.14. So the mode is just the value that repeats the most often in a data set. In this case, there's 4 threes, 1, 2. I'm sorry, there's 3 threes, but still there's no other value that's repeated that much. The 5s repeat twice and the 12s repeat twice. So 3 is the mode. So the mean is just add them up. So 80, and then we divide by 5. So 16. So the median is when we got to order them. We have to order them. They cannot be like they are now. They have to be ordered, smallest to largest. One, two, three, four, five, six, seven. And so when you've got an odd number of pieces of data, there's going to be one value in the middle. One value. And it would be that one right there. All right. Because you got exactly 3 on each side. So 26 is the median. The mid-range is just take the 2 extreme points, the high and the low, and divide by 2. So it's 43. plus 65 divided by 2. Uh-oh. I think I did something wrong. 65. Yeah, that one is, I got in there is wrong. 65 plus 43. I don't know where I get that other one out. But it'd be the one in the middle, the midpoint. All right. What about number 6? I explained that one earlier, but did anybody not get the logic behind that? If you do everything to something to every data point, add, subtract, multiply, or divide, and then calculate, it's the same as doing the calculation and then doing it to the final answer. All right. Well, thanks, Adam. So on this, see, it's half 48. So 48 divided by 2, or 48 times 1/2, minus 4 gives us the 20. Now, this one provides an opportunity for us to test them all out. I have to say, I don't particularly care for this question because when it says best, they need to give you some criteria. But in this sense, because the mode here, 32, 32, 32, 32, there's your mode. That's the most likely measure of center,
And
the best one.
I
But
picked
it's a
mode
it's a
first time. I picked mode the first time and it said it was wrong. And then so I just tried mean and it said it was right.
which one did it say?
It said mean was right, which didn't make sense to me, but
Well, I'll try to make sense for you. Because here's the thing is, when you ask something like that, when you said best, and they don't explain to you what the best is, then it presents a problem. So yeah, we just got to kind of look at their logic and memorize it. So let's see if I can tell you. Well, the mode is the one that repeats. If we did the mean, it takes, and let me just say this: in almost all cases, the mean is the one unbiased estimator that we have because it takes every one of the values into account. So I'm just going to write this here just to kind of sum this up so that maybe we can remember that that's what we need to do is just pick the mean. So remember that, and that'll help you answer that. So just if you answer the mean, like I said, that's usually the best answer because of the fact that the mean is the only unbiased as measure of center because it takes every one of the values into consideration. Because the median, you're only looking at the extremes, and then for the mode, you're looking for the one that appears the most often. And then, okay, with this one, we'd also kind of talked about this. The mean gets bumped up by that value right there. Because the other thing that we can say, the mean is affected by extreme, or let me say, is sensitive, extreme values. All right. So that 200 is going to cause the mean to shoot up. If you would calculate the mean without that 200, it comes out to like 96 or something. But if you throw in the 200 and then divide by 8, all of a sudden now you'll see that it jumps up. So the outlier is 200. The outlier is always an extreme value. And the mean is the one that gets affected by it. All right, and anytime we're looking for normally distributed data or symmetric data, we just look for symmetry in the graphs. All right, if you have symmetry in the graph, then that means that there isn't any skewness, like this shape. All right, the shape of these curves here. All right, that's what we call symmetric or normally distributed data, like the one here, see? Now, in reality, when you're drawing a graph, it's not going to look like that because that's all nice and smoothed out with a lot of data points on it. When you're just working with a finite data set, you kind of got to use a little bit more imagination. You kind of just watch. And see that that is more or less the pattern. Starts out slow, down at the bottom, goes up, reaches a peak, then comes back down. If you have that kind of thing with a histogram like this, then you can say it's symmetric. Symmetric. Right skewed data is going to look, well, here's the two types of skewness. Right-handed skewness, in other words, the extreme values are on the positive side, so that's why you got a tail over there. Left skewed data, the extreme values are on the negative, on the lesser side, and they're pulling things towards the left. And then the one where it's like up and down, like I said, this is symmetric. You can tell the mode by just looking at the value that's got the most in it. You can even do that with this right here. It's just a chart. These are what we call the ungrouped data. So the one that's got, there's only 4 different categories: Twitter, WhatsApp, Facebook, and other. So WhatsApp is 125. That's the one that's the most. So that would be your mode. So if everything in the data set is all clumped nice and close together, then you have a small standard deviation. So in this case, most consistent. In other words, they were all pretty much close together, no way out outlier values. It's the one with the lowest. So in year 2016, the times were more consistent because the standard deviation for this year is the smallest. All right. So how comfortable y'all feel with standard deviation? This one is kind of long because the mean is, it's not an even number. It's a decimal value. So I may have even messed that up. So I do want to go back through it, but I'm going to, yeah, I mean, this is all from statistics class. I mean, some of this stuff we even go over in 203, like the first half of the class, there's a lot of overlap. All right, I'll tell you what, my brain's getting worn out, so I'm gonna use my little calculating tool here. All right, so what do we have here? All right. Four one zero. That's not right. 1, 2, 3, 4, 5, 6 values. So the mean should be, and that's what I had before, so I was right. And this is what I had. I was hesitant about that one because it just didn't look right. Oh. All right, so then the sum of all these should be near zero. Yep, magic. That's how you know you're right, is of all your deviations. These are you call your deviations, and that's the ones where the difference between the mean and the value. All right, so here's the squares. All right. So now and so square root of that. Oh, wait a minute. I'm sorry. I got to do, first of all, I got to do the 1, 2, 3, 4, 5, 6, 7. This is the population. And I think they always do population. So we're just going to divide by 7. So this is the one divided by 7. So that's what's going to be there. So that's your variance. This is your variance. And then your standard deviation is just going to be the square root of the variance. 2 point. And that's exactly what I had. Good. Don't feel crazy now. I just was worried about it because it's easy to make a mistake. All right, all right. So again, when you're talking about standard deviation and skewness, the standard deviation, when it's smallest, you're looking for a more compact grouping of data, because if it's really spread out, then the standard deviation gets larger. It's like that curve, okay? See that? The difference between the skinny one and the green one, which is the fat one? Well, the standard deviation is larger on the one that's fatter, that looks like it's been stretched out. So that means the standard deviation is larger. So for that one, the smallest standard deviation is C. The largest standard deviation would be D, and then this one and that one, and the smallest. So anybody got any questions on that one, the variance? That's essentially the same thing as the standard deviation one, except that you don't do the square root. You just, once you get the sum divided by the n, so I'll tell you what, I'm gonna do this one real quick over here just to make sure it's right. So 6, 3, 14, 11, and 6. All right. So let's say the mean is 9. So this is the deviation. So this is, I feel more confident about this one. But I want to go back through it. All right, so these should all be 0 if we did everything right. And look at that. So the sum of your deviations should all be 0. Now we're going to square them. So 6 negative square root of 6, 5 square root. So that's right. So then this is the sum for your numerator. 108. And then the final answer is 108 divided by, so this is your variance. $108 divided by, and it was 7. So there's your variance. If you wanted the standard deviation, you would take the square root of it. But we want the variance. So this is what we want. What did I do? Why have I got 18? It was 7, wasn't it? 1, 2, 3. Oh, it's 6. It's 6. I'm sorry. The one previous one was 7. There we go. So 18 was right. 1, 2, 3, 4, 5, 6. All right. Well, I think we're just about done most of these. So smallest standard deviation means better. So Dakota z-score of 0.1 and Jamie's. Let me look at something over here. Oh, and I was going to say, so tomorrow I'm going to have the test start during the morning. You can come at 11 and if you got questions, but make sure if you take the test and everything goes fine during that time, that's great. But if you have any problems with the honor lock, then come and meet with me, and we're going to meet it and Zoom it. But like I said, I'm hoping this will work out just fine, because then that's what we got to do for the final exam. And so if this works, I'll be much happier about the exam working correctly. All right, so
I got a completely different.
let me you know what?
Because it says to find the z-score.
Yeah, I apologize. I was just noticing that. Use the information given to calculate each runner's z-score. I didn't see that. I apologize. So we got to calculate their z-score. And so once we find the z-score, then that'll tell us who's faster. All right. So we can. That wasn't a z-score. That wasn't a z-score. And then we don't know if that's the answer. So let's go ahead and calculate the z-score for each one. So this is BZ for Dakota. So and then the Z code for Jamie is All right, so let's handle each one of these. So this one is -2. So this one is there we go. So now we're looking for the lowest z-score. So Dakota's -2.0, -3.0, and this means that Jamie. All right. Okay, good. Yeah, I just when we went through that was going quick. It was getting towards the end of class, and I neglected to read that part. And I know now that we needed to do it. There's no way to compare without doing the z-score because you got to compare because they both have a mean that they're comparing to as well as a different time. So yeah. So what about the empirical rule? Y'all feel good about that? I'm going to go
No,
back
I
through.
don't.
Anybody?
That's the only thing I've been having like real problems with.
Well, the empirical rule is essentially
My problem is remembering all of the rules.
yeah, well,
Yeah, I mean, I have them all written down, but I mean,
you
yeah, it's
you
Yeah,
memorizing
for
them,
the test, you can't have it. So it's like, wait, I gotta remember it.
right?
yeah. So for the empirical rule, one standard deviation, in other words, this chunk in here from the red to the red is 68% of everything underneath that curve. And everything underneath that curve, remember, is 100. And then if we go another standard deviation on either side, 2, it brings us to 95%. And then going one more on each side, -3 to 3, gives us almost all of it, or 99.7. So with that being said, how many standard deviations is it from 1204.9 to 1454.1? That'll pretty much give us our answer. It needs to be the same on the subtraction side, but how many standard deviations in that? Well, the standard deviation is 1.24. So let's find out how far that is. So I'm going to subtract. And certainly that's more than 1, but I'm going to divide by the standard deviation, and that'll tell me how many. So that's 2 standard deviations. Okay. Well, let's just check to make sure that on the left-hand side that that is 2 standard deviations as well. So 14, I'm sorry, what is it? 1204.9 minus 955.7. And now that's that same value. So let's divide by the standard deviation and see that's 2 as well. So 2 standard deviations gives us 95%. And that's where that 95 comes from. Most all of these now we're just calculating so let me know what you think about this one if you want me to go through it.
I think I'm good on that one.
Anybody else? This is basically just solving for that missing standard deviation, because they tell you the number of standard deviations. They give you the z-score 3.7 negative. All right. And so they give us 181. That was his X value. And then this is what we don't know. That's a variable. So essentially what we do is solve this equation. And what I'm doing is I'm just cross multiplying like that. And then 1 times that is not changes, and it's just 181 minus 210. And so negative 3.7 sigma is what? So negative 29. So then to solve this, we divide both sides by negative 3.7. So see, then that's going to be sigma is equal to 7.8. That's a lot of standard deviations. That's really a extreme value. And it's an extremely low value. All right, and this right here just means that the data set, this right here just means approximately the squiggle, normal with a mean of 11 and a standard deviation of 0.5. So that's just a notation. The X is approximately in normally distributed with a mean of 11 and a standard deviation of 0.5. So then they want us to find the z-score. So z of 12, and that's what they're telling us. So then that's 12 minus 1 is 1. 11 is 1. So then this is also 2. So the z-score for 12 is 2.0 and the mean is 11. So what that's saying is that the score 12 is 2 standard deviations above the mean. All right. I got a student's got a question. Let me send one out, and then y'all got anything, I'll keep going. All right. So what's going on? Y'all want to see anything else, or y'all happy? Okay.
Can we do number 25 again? Because I had 0.15.
That's that one that we were talking about earlier, right?
No, it's the last one. You got 13.
Yeah, 0.13. All right. So a normal distribution is observed from the times to complete an obstacle course. The mean U is 69 seconds and the standard deviation is 6 seconds. Okay. So using the empirical rule, in other words, we calculated before, and as I remember, this was 3 standard deviations.
Yeah.
Okay, enough of that. Three standard deviations, right? All right. So what they want is, what is the probability that a randomly selected finishing time is greater than 87 seconds? Now, 87 seconds is 3 standard deviations. All right. Where's that thing at? There we go. Somewhere here. So that means then that it's this little chunk up here. Now, those lines just don't go down there and sit on that line. They're just getting closer and closer, and then they don't ever get there. All right. So there's a little bit of area over here. And what it is between 3 standard deviations is 99.7. All right. So if I do that as a decimal, 1 minus 0.997. So that means that on both sides, lower than 3 negative and higher than 3 are the values that are 0.03. Okay. So if I want half of that, which is the half on the top, then it's 0.0015. I was trying to so that should be your answer there, right there. So if you use it using the empirical rule, you get the right answer. I just when I done it earlier, I had used this to show you that the exactly answer would be 0.003, but they do say to use the empirical rule. So the empirical rule is just going to be half of the missing
Right. Okay.
0.003%. All right, so see y'all in the morning. I'll be in here before 11, just waiting around. If you got any questions, if you want to come around and shoot. If you want to just come to the morning one and then wait till 12:30 to test. Okay?
Okay, so are we doing 11 o'clock?
Yeah, it'll be if you're ready, or if you want to come to class, it'll be open, but you can pop in for class Zoom if
Okay.
you want.
Okay.
But it's
All
just
right.
got to be done by the wrap up time of 1:45.
Gotcha. All right. Thank you. Bye-bye.
Okay. All right, Adam. See you tomorrow. You got a question, Chantel?
Hey, no, I was just trying to I was trying to leave the Zoom and I don't know what I'm hitting.
All right.
But I see you in the morning. I'm gonna try to come early in the morning to make sure that my honor lock is working because remember I had trouble with that. So I'm gonna come early to try to square that out. And it's just for the final review, are we going over any of that materials this week?
Well, it'll be on Wednesday, the last day of class.
Okay. Thank
I
you
mean,
so
if
much.
you take your test and you want to come in and ask me any questions tomorrow, free to do that. I mean, but that's just what I got on
Okay.
the schedule is we'll deal with it Wednesday,
Okay, okay, thank you
but
so
I'm
much.
here
Have a,
tomorrow for you. Okay.
thank you. See you tomorrow. Take
All
care.
right. Bye bye.
Bye-bye.